2nd, 2011. You guys are on textbook page 295, blue notebook page 279. Today's a pretty important day. We have a federal election. Osama bin Laden is possibly dead. But more importantly, we are on lecture 5.4. Okay, we're working with cosine law. So we've gone over all of our trigonometric ratios, our SOHCAHTOA. Let's do a recap of that, just to make sure you understand that it is written sine, theta is our angle, over opposite over hypotenuse, cosine, theta, which is the angle adjacent over hypotenuse, and tangent is tangent theta opposite over adjacent. Make sure you have that memorized. Those specifically, better mention this, those are for right angle triangles only. Those three laws. Right angle triangles only. So 1, 2, 3, only work with right angle triangles. We learned sine law the other day, which is for non-right angle triangles, and cosine law for non-right angle triangles. Make sure you know the difference for your test on Thursday. If you have a right angle triangle, you use one of those three ratios. If you have a non-right angle triangle, you either use cosine law or sine law to solve it. Doesn't matter. But these are the types, this is the information you'll need in order to use cosine law. So we had three different types with sine law. With cosine law, if you have a side, angle, and side, so let's say, as you guys see right here, we have the measurement of this side, the measurement of that side, and the angle in between. We would be using our cosine law to solve for the other sides of that triangle. Or if you have the measurements of all of the sides of the triangle, you would use cosine law to solve for the angles in the triangle. Okay? Do you guys have any questions about that? We have that? Good. Make sure you have this memorized, just like you needed to have sine law memorized, just like you needed SOHCAHTOA memorized. We'll do a little recap at the end before the test. We're going to go on to our first example. Example 1. So this example is on page 296. Okay, they've given us a triangle. And for your test, just to give you a heads up, there are, on many of your textbook questions, they've given you diagrams. There are no diagrams on your test. Your test will have something like this. Side A equals 36. Angle A is 42 degrees. Side B is 28. And you need to construct the triangle from that information. Well, you won't get any marks if you don't do it right. We'll see. I might give you one. So, textbook questions are a little easy. A good example to be looking off will be our problem-solving questions where they, in words, give you the measurements of the triangle. But let's go to our first example. We have triangle ABC, 7 centimeters, 43 degrees, and 5 centimeters. Importantly, if this is, what are they asking us for actually? They want side C. So, which is side C? This one, or this one? That one. What a great description. Between A and B. Very good. That is side C. The reason that is side C is because it is opposite of angle C. Okay? That is opposite of our angle C. There is our side C, which means 5 centimeters would be called which side? B. Opposite of angle B. And 7 centimeters is A, and also known as our what? That's the wrong side. Good. Okay. let's set up our cosine law. We have side C squared is equal to side A squared plus side B squared, subtracted by 2 times side A times side B times cos angle C. Not much to remember. I'm sure we do some practice with this. So, let's try to color code this a little. We have our side A, angle A, and our side A, angle B, side B, and angle C, side C. Okay? A big thing with cosine laws when you guys are going to set this up, the side that you call C will probably be the side you have an angle to. Make sure you call that side C, because if you notice, there's only one angle in cosine law, okay? In the formula, that is. So, you can name any side A, B, or C, but it's in your best interest, if you have the measurement of one angle, to name that side C in order to set up this formula properly. So, we're still looking for side C. We don't know what it is. So, the only variable in this formula that is an angle is this right here, C. The rest of these are sides. So side, 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 and side. There's only one angle in this formula. Okay? And that's that one there attached to cosine C. Just going to pause that formula for a second. On your test, if you're given some sides of a triangle, if none of the angles you're given say 90 degrees, do not assume it is a 90-degree triangle. Assume it is not 90 degrees. Do you guys understand that? So even though this triangle here looks like it's 90 degrees, I can't technically prove it right now. It might be 89 degrees. It might be 91 degrees. I don't know. So I'm not going to assume it's a right angle triangle. I'm going to assume it's not and use cosine law. So let's keep going here. So we have our C squared is equal to A squared, so side A is 7 centimeters, plus side B is 5 centimeters, minus 2 times 7 times 5. That's our A and our B. Cosine 43 degrees. Okay? So I'm just going to underline those colors just so you know. That was our B and our B. A, and this was our angle C, 43 degrees. From there, we're going to be using our calculator to solve that. So, okay, so let's try to keep going here. We're still looking for C squared. 7 squared is 49. 5 squared is 25. 2 times 7 times 5 is 70. Times cosine 43. C squared equals 74 minus 70 times. Let's figure out what cosine 43 is. So we're going to plug it in here. Cos 43 equals 0.731. We'll leave it at that. 0.731. My next line, I'm going to figure out what 70 times that is. Oh, I shouldn't have cleared it. Let's try that again. I could have done that all in one shot, so I'll show you. We could go cosine 43 multiplied. Let's make sure we do it in brackets. Cosine 43, so note that first, times 70 equals 51.194. C squared is equal to, okay, many of your calculators will have this function. You can go 74, I just can't see it from here. And you can type in the answer from the previous calculation. So I push second, and see how there's a little A and S there? Oh, I meant to push subtract. I screwed it up. Let's try this again. 74, subtract the answer from above. So I didn't have to type that number in. My calculator remembered it, put it in for me. Equals 22.805. And finally, I'm not just looking for C squared. I need to find C. So I need to square root both sides of this equation. I need to square root both sides of this equation to solve for C. So in the end, that C will equal, look at it over here, square root of the answer above equals 4.77. So, in the end, our side C was 4.77 centimeters long. Do you guys have any questions about that? Okay, example 2. On a test, you might get something like this. It'll probably be written in a sentence, but essentially it'll just tell you that side R is 3.2 kilometers, side Q is 6.2, side P is 5.9. Determine angle R. So first of all, they haven't used an A, B, and C, and technically it doesn't matter if they're using an A, B, and C. We have to name these in order to use cosine law or sine law. So we got to figure out, which one we're going to do. So I'm going to construct a triangle. So I have my triangle here. I'm going to name this one angle R. So this will be my side R, which is 3.2 kilometers. No, we're going to go angles uppercase. Okay? We have our side R. We're going to call this angle Q, so this will be side Q, which is 6.2 kilometers. And finally, side P and angle P, 5.9 kilometers. So, in other words, they want us to solve for this angle right here. That is going to be our angle R. So we have three sides of a triangle, which means we're going to be using cosine law. Okay, so we've written cosine law down. If you guys remember cosine law, we've written it with A, B, and C. They've given us an R, Q, and P. That means I need to rename my triangle, and one of our variables has to be correct. The other one, the A and the B, they don't really matter, but our C has to be done correctly. So C needs to be the angle we're finding. So since we are looking for R, side R will now be our new side C. Angle R will be our new angle C. The other two, doesn't matter. I'm going to call that A and that A. I'm going to call this B and B. Make sure when you're using cosine law, whatever angle you're trying to find, whatever angle you have, that is your side C when you go to set this up. So, okay, so I've plugged in our side C, A and B. There's A and B again, and we're still looking for angle C. We've plugged them into the cosine formula. We're going to have to solve these all. So, let's get our calculator out. I'm going to quickly square these so you can see what they'll look like. Okay, so I've quickly squared everything. We're going to combine them quickly, keep solving here. So, 10.24 equals, okay, we have that written, 10.24 equals 73.25, subtract, and we'll show you how to do this part. 5.9 times 6.2 times 2 equals 7316 minus 7316 decimal, 73 decimal 15, cosine C. Okay, I need to isolate for my C, so I have to bring the other numbers to the other side of the equation. This will become 10.24. When 73 goes to the other side, it becomes negative, equals, this still says negative 73.16 cos C. I'm going to combine these two on the left, 40 seconds. Okay, so now that I have this, I have to isolate C. The first thing I'm going to do is I want you guys to imagine that negative 73.16, oh, there's an extra one in there. It should only be 16. Okay? 0.16 is one number, and cosine C as another number. So in order to move that, I need to divide this side by negative 7316, and I need to divide this side by negative 7316. So when I'm doing that, okay, so I've solved for my left side. I'm left with cosine C on the other. I still have to isolate for just this C. So when I bring cosine to the other side, it becomes cosine inverse to 8.6126 when I type it in my calculator. Okay, so C we discovered was equal to 30.54 when we did our cosine C.